The Big Bang Theory is the most widely accepted explanation of how the universe came into existence. According to this theory, the universe began with a single, extremely dense and hot point known as a singularity, and then rapidly expanded and cooled over billions of years to become the vast and complex universe we observe today. In this video, we will explore the evidence and history of the Big Bang Theory, as well as its implications for our understanding of the universe. The evidence for the Big Bang Theory comes from a variety of sources, including observations of the cosmic microwave background radiation, the abundance of light elements in the universe, and the large-scale structure of the universe. One of the most compelling pieces of evidence for the Big Bang Theory is the cosmic microwave background radiation, CMB, which was first discovered in 1964 by Arno Penzias and Robert Wilson. The CMB is a faint, uniform radiation that pervades the entire universe, and is thought to be the residual heat left over from the Big Bang. The CMB has been observed by numerous satellites and telescopes, and its properties match the predictions of the Big Bang Theory with remarkable precision. The abundance of light elements in the universe, such as hydrogen and helium, is also consistent with the predictions of the Big Bang Theory. The theory predicts that these elements should have been formed in the early universe when it was hot and dense, and that their abundance should be related to the density and temperature of the universe at that time. Observations of the relative abundances of these elements in the universe are consistent with these predictions. Finally, the large-scale structure of the universe, including the distribution of galaxies and the cosmic web, also provides evidence for the Big Bang Theory. The theory predicts that the universe should be expanding and that the galaxies should be moving away from each other. Observations of the redshift of light from distant galaxies confirms that they are indeed moving away from us, and the pattern of this motion is consistent with the expansion of the universe. The idea that the universe had a beginning is not a new one. In fact, many ancient cultures had creation myths that described the universe as being created from nothing. However, it wasn't until the 20th century that the idea of a scientific theory for the origin of the universe began to take shape. The first steps towards the Big Bang Theory were taken in the 1920s, when astronomers discovered that the universe was expanding. This discovery was made independently by Edwin Hubble and Georges Lemaitre, who proposed that if the universe was expanding, it must have been smaller and denser in the past. In the 1940s, George Gamow, Ralph Alpha, and Robert Herman proposed that the early universe must have been very hot and dense, and that it should have produced a detectable amount of radiation that is still present today as the cosmic microwave background radiation. The term Big Bang was first used in the 1950s by Fred Hoyle, who intended it as a term of derision for the theory. However, the name stuck, and today the Big Bang Theory is the most widely accepted explanation for the origin of the universe. The Big Bang Theory has profound implications for our understanding of the universe. It tells us that the universe has a finite age, and that it has been expanding for billions of years. It also tells us that the universe began with a single point of extreme density and temperature, and that all matter and energy in the universe was created in that instant. The Big Bang Theory also provides a framework for understanding the evolution of the universe. It tells us that the universe has gone through several distinct epochs, including the radiation-dominated era, the matter-dominated era, and the current dark energy. This physics tidbit is brought to you by Michael Kaminsky, for a better world.